Hello, everybody. It is 9:01. Hey, we have an audience today. I have two students. This is great. So welcome. And so we only have 2 weeks of class left, if my notes are correct. We are currently in week. Oh, there's a chat here. Let's see. Good morning. Oh, okay. Well, good morning back at you. We are currently in week 7. So I'm just going to get right to it here. Let's see. Let me see if I can share the screen. I'm going to share it with Safari. There we go. Oh, we don't need this one. We need, let's see. There we go. Let's see. So today is, I should know this stuff, July 15th. Let's see, on July 15th, we are in week 7. And this week we have assignment number 6 that is due. And so we have this week, which is about halfway done. Then we have next week, which is week 8, which is the official last week of the class. And the assignments are due on the 27th. And that one, I believe, is going to be your last assignment, assignment number 7. Now, assignments number 6 and number 7 are no-brainers. You're just answering 5 questions that come out of the reading. The most important thing is to actually do the reading and see if you can answer those questions. The questions are a bit abstract. There's no right or wrong per se question. There's categories of right and wrong. So the category of the right would be things that would fall into examples or ways that the concepts could be implemented. These questions come from the back of the chapters. I didn't make those questions up. I stole the questions from the textbook. So if you're wondering why the questions are so hard, we'll take a look at the textbook reading, and you'll see the questions back there. These are maybe not the exact questions, but they're formulated as parts of some of the existing questions. But long story short, you need to read chapters 5 and 6 in order to answer those questions appropriately. Okay, because that's where the information is coming from. So let's go back to the schedule here. I misquoted in my last video. I said I was going to change this to a 7-day window. I just realized why I wrote 5 days here to begin with. The final exam week is 5 days. I can't change that. I looked it up in the policy manual. The final exam week runs Monday, July 27th through Friday, July 31st. So I have to stop the class on Friday, July 31st. I am not allowed to run Saturday. The term is officially over on Friday, July 31st. So make sure you schedule between Monday through Friday the final exam, which won't be available until next week. I might put it out early next week, and now about midweek during week 8, maybe Wednesday, Thursday-ish. It might be available. You might be able to take it the weekend before. As soon as it does become available, I will send a message out to the class, an announcement, to let you know that the exam is available. You may take it early if you'd like, but you cannot take it past Friday, July 31st. So I hope that is clear. Again, I will be posting it next week. I'll let you know by email or by class announcement, and or both probably, when it does become available. I'm going to try and make it so you could take it over that weekend, which is next weekend, not this coming up weekend, but next one. But it is due by Friday, July 31st at the latest. There is only supposed to be a 5-day window. I'm not actually supposed to allow you to take it early, but I don't think it's going to matter. It's only going to be like a weekend early, so it's not going to be that big of a deal. All the assignments and everything must be submitted by Friday, July 31st if you want to get credit for it. So if you're back, you're missing some assignments from the previous weeks, make sure that you catch up by July 31st. That is the final day that I'm allowed to accept anything from you. So just keep that in mind. So what I want to do today is go over the chapter readings, chapters 5, 6, 7, and 8 in the textbook, to let you know what it is that you need to study and what it is that you need to read in order to prepare for that final exam. Final exam is worth 35 points, so it's significant. You should be able to see your current grade in the grade book at this point. You know, give or take any assignments you recently submitted that haven't been graded yet. But everything should have been up to date on Monday. So let me switch over now. I'm going to stop this share. I'll wait until the very end before I ask for any questions. Let's see. There we go. Got the textbook here. Got the textbook. There we go. So you should be seeing at chapter 5. Chapter 5 is on names, bindings, and scope. The entire chapter is testable material. So let's just take a look to see what's in the chapter. Obviously, the introduction section. Wow, the introduction is good. Design issues associated with names and name forms, how naming is used, special words, variables, names, addresses. So the concept of names as outlined, and I'm gonna just kind of, you don't need to know the historical notes, by the way. I'm not gonna test you on the historical notes, but you do wanna read about names. You also wanna read 5.3, which is on variables. This entire chapter is good. There's nothing to skip. Concepts of bindings, which is 5.4, and the binding concept, which is actually has already been introduced in a previous chapter. But binding is also good. Scope, it's not that mouthwash you buy at Walgreens. It is a concept in programming language concepts, so scope. Visibility of variables and environments is also good reading. Scope and lifetime, the lifetime of environments. Referencing environments, visibility, that's also good reading. Named constants, you can skip a named constants. You don't need to know about named constants. You probably already know about them. Read through it. I'm not going to ask you anything about the C# language though, and you're not going to get anything about constants. So don't stress on the named constants, which is section 5.8 out of the version of the book that you're looking at here. It might be different in the version that you have. So you don't actually have to know anything about any particular programming language. If there were a question, it's going to be about general languages. So for example, in Java and C#, how long can a name be? I'm not going to ask you those specifics, like 12 characters, 16 characters, 25 characters. No. I might ask you something, you know, about what is a reserved word. And again, this is a multiple choice true false exam. So you might say, you know, what is a reserved word? A word that is built into the language. B, a word that cannot be used as a variable name, as an identifier. C, one that you check out from the library. I don't know, I probably won't ask you that. So you'll be able to logically guess. What is the address of a variable? That's an interesting question. What is a variable? How can a variable be characterized? What's the type inference? So yeah, these are good questions. And you know, you can test your knowledge by seeing if you can answer these questions, but skip this stuff. I'm not going to ask you like specifics, what's the length, or what is it in a particular language. Excuse me, a little bit of allergies. Let's see if I can get my voice back. There we go. Getting it back. Oh yeah, I'm back. What's a block? So see if you can answer these questions. If you can't answer these questions, you might want to reread the chapter, or you know, try to answer these questions. If you can answer these questions, you're going to ace the exam, because my questions are not as hard as these questions. So that is chapter 5. Chapter 5 is testable material. Read chapter 5. Chapter 6 is a simple, easy peasy chapter. Chapter 6 is on data types. If you're a programmer, if you've programmed before, Chapter 6 is your chapter. It's your easy read chapter. Go ahead and read it anyway. Read it anyway, because there's some data types in here I might ask you about. I might ask you about a tuple. Well, you saw the tuples in assignment number 2 because Python supports the tuple. You've seen records. Those are structures in the C language. Associative arrays, that's a Python feature. Now, if we used the language in the class, for example, Python, Scheme, Lisp, Prolog, if we use those languages, and we did, then I might ask you about a data type. For example, there might be a true-false question. So this is, are tuples supported in Python? True or false? Or, tuples are supported in Python, true or false? Or the union is considered a record type in the C language. Now, C is testable because C is the language for the computer science program, if you haven't figured that out already. C, C++. I'm not going to ask you any object-oriented questions about Java or C++, however. Just keep that in mind. So data types. What do we got going on with the data type chapter? Let's see. The introduction is good reading. Go ahead and read the introduction. That's good. In fact, the entire chapter is testable material, by the way. 6.2, primitive data types. Those are built-in data types into the language, like the integer, the float, the double. Now, I'm not going to ask you about descriptors. You probably don't even know what a descriptor is, or maybe you do. Type descriptors. I'm not going to ask you about the length of the data types. You don't have to know how big a float is or a decimal. And you don't have to know about anything about COBOL or C# or F# or any of these other languages that are in here, these weird languages. A Boolean type, character types. It's testable material. Enumeration types are testable material. Array types, obviously. Associative arrays and arrays themselves. Forget about the historical notes. I'm not going to quiz you on that. Record types. Now I sound like Forrest Gump. Tuple types, list types, union types, fish gumbo, pointer and reference types. Yeah, pointers and C. Focus on the design issues, design characteristics. It's going to be good stuff. Pointer problems. Type checking. The concept of type checking is good to know. A strong versus weak typing. Now, I'm not going to quiz you then say that C is a strongly typed language, true or false, or C is a weakly typed language. Because there's a bit of variance between the definitions of strong and weak typing. In fact, if you go on the internet, you can see about 50% of the time, people think that C is strongly typed, and then 50%, the other 50% of the time, people think that C is weakly typed. Because unfortunately, there's two definitions of typing. If you learn anything from this video, here's your value add for watching it. Not because it's going to help you, because this question is not on the final exam. But you might be finding that not everything you read on the internet is true. So the original definition of typing, strongly typed and weakly typed, was a language was strongly typed if all type errors were corrected and checked. So they said, well, C has type checking and all type errors are supposed to be corrected, therefore the language is strongly typed. So then a weakly typed language didn't have type checking. So they said, oh, well, Python doesn't do static type checking, so Python must be weakly typed. And the definition holds true 50% of the time. And then there was this new definition that came out. So I call this like urban legend. Actually, really, it's the blind leading the blind. Somebody wrote on Wikipedia or one of these tech websites that the definition between strong and weak typing was that strong typing was when you explicitly mentioned the type. So like in the language C, when you went integer I, float F, But that was strongly typed, which is incorrect, by the way. But it's all over the internet. It's one of those urban legends of incorrect information that keeps getting repopulated all over the place. And generations of college students have looked at that and went, oh yeah, strong type when you have to write the type. That's actually called explicit typing versus implicit typing. So through the years, implicit and explicit typing got confused with strong and weak typing and became the same thing, which is wrong, 100% wrong. So just so you know, that is not correct. So they mixed it up. Some stupid idiot wrote it down on some website. Somebody copied it. Somebody's been repeating it over and over again. And college students answer for decades and generations incorrectly. Actually, it's only been going on for about 10 years. But that's long enough for something that's fake to actually become true. And if you haven't realized it, and if you haven't been keeping up with social media, fake news, and all the other stuff that's going on, and maybe you have just crawled out from under a rock and you didn't know that the last election was fixed or rigged through fake news and propaganda, you know, we have a serious issue on the internet these days with false information being spread and believed by people. Just go on and Google any topic you want. Don't trust what you read on the internet. That's why, you know, if you think about it, textbooks and printed materials are more valid these days than what you find on the internet. And I know some of you are Googling answers to the questions on the assignments on the internet because I keep seeing the same crap repeated over and over again, especially when it comes to assignments number 6 and 7 when you're answering questions. Just think about it. Most of the stuff you're copying and pasting and cheating with, if you're doing that, and I'm not trying to insinuate that anyone in particular is doing that, but I have seen repeated answers that are just like, oh, I know where they got that from. I'm not going to correct you on it. I'm going to give you credit for the answer, but know that how do you really know that what you're finding is actually correct? Just because it's on the internet doesn't make it true. And I want to say that, you know, maybe 5 years ago, it was about 50-50. Today, let's just say in modern day, like this year, it's like 70-30. 70% of the computer science information out there is completely wrong, and only 30% of it's correct. So you see all these websites with all this crap about how to fix problems. You know, oh, if you're getting this error in C, you should do this thing with namespace or something, or you should do that. All these like Stack Overflow and Rent-A-Coder and all these websites out there, 70% of the crap that's out there is garbage. Not true. You can figure this out every time. If you've ever tried to troubleshoot a problem, you're trying to do an install and you're getting an error and you Google it, and you find like 70% of the answers that you're going to come back with is garbage. They're totally wrong, totally not the good solution. And only 30% of it is actually really valid. And so you look for that 30%, you find something and that one little thing works and hopefully you can solve the problem. Okay, that's an issue. That's an issue in my mind. So anyway, I'm off my soapbox, going back to the book now. Some people find my little anecdotes entertaining. Some people I get like, okay, can you just get back on topic? All right, so I'm back on topic. All right, type equivalence, types being equivalent to other types. Okay, theory and concepts of data types. This whole chapter is good. Read the summary as well. And let's see, at the end of this chapter, we get some lovely little questions. What's a data type? That's good. What are the advantages of the data structures of COBOL? You don't have to know that. Nothing about any particular language. So you don't have to know that. What is an abstract data type? Well, that's a good one to know. What's the difference between using a type system of a program? Or describe the different uses of a type system, like programming language. Again, you don't have to know about descriptors. Don't worry about the descriptor. Cross that question out. What is the use of a Boolean type? This chapter is actually pretty easy. So that was chapter 6. Read the whole thing. Let's go on to chapter number 7. Chapter number 7. has got expressions and arithmetic statements. We got an introduction, we got arithmetic, we got overloading operators, that's good. Type conversions, relational and Boolean expressions, short circuit evaluation. Some of this stuff might actually look familiar from the assignments that you've done. So let's see. This whole chapter is going to be readable as well. There's not too much to skip out of the second part of this class, by the way, but the material is lighter weight. If you haven't noticed, chapters 1, 2, 3, and 4 are pretty heavy duty. Chapters 5, 6, 7, and 8, they're easy if you've done any programming before. All right, so read the introduction. Arithmetic expressions. I'm not going to ask you about precisions, about rounding. But you might be familiar with the operator evaluation order. I'm not going to ask you about what the operator evaluate. You probably know this from taking math classes. I'm not going to ask you details about which language uses how many levels of operator precedence are there in the language of C. I'm not going to ask you those specific questions either. There's no number of questions about that stuff or even about the level. Overloading operators, the concept of what are you doing when you're overloading an operator. If you took the CS courses, you already know about how to overload operators in C++. That's the scope. So you don't have to worry about C#. There's a lot of C# in this book, I'm noticing. So I guess I figured C# was going to be popular at one point. That's not. Hate to burst your bubble, but C# is not a language worth looking into. Relational and Boolean expressions, skip the historical notes. We don't need to know about Fortran either. Boolean expressions, short circuit evaluation, assignment statements, mixed mode. That's taking a float and adding it with a double. You know that Python supports mixed mode operations. C does not, because it is an explicitly typed language that does type checking, but you know what? C is not a strongly typed language. Although 50% of the internet thinks it is. Okay, so define operator precedence and operator associativity. That's a good question. You should be familiar with it. What is an infix? What is a unary? Yeah, you should know this stuff. Overloading operator. Here's one you don't have to know. What's the difference between the way exponential operators are implemented in Fortran and Ruby? I didn't talk about Fortran or Ruby in this class. Although if you're interested, forget about Fortran. That's something from the past. But Ruby and Ruby on Rails is not so bad if you want to do internet development with databases. It's pretty good. Scope for another class though. Not this class. Mixed mode assignments, are they allowed in ML? We didn't talk about ML, you don't have to worry about it. We don't have to talk about Java. We did look at Python though, and I will tell you that mixed mode assignments are allowed. So if I were to answer this question, for example, what mixed mode assignments are allowed in, and I substitute Python instead of Java, I say you can add any numbers you want. So you can take floats, doubles, as long as it is a number category, the mixed mode works. You can take an int and add it to a double or a float, something like that. You can also concatenate characters with strings. That works as well. So, what is a cast? You probably are familiar with this concept of typecasting, especially if you've been taught that in C, converting one type to another. So. These are good questions. They're very good questions. Don't worry about the problem sets. Be more concerned with the review questions. No problem sets. All right. Last but not least, we have chapter number 8. Chapter number 8 is the statement level control structures. The introduction, you want to read this whole chapter. Ooh, guarded commands are not testable. All right, so let's see. I'm going to go by section. Introduction, read the introduction. The introduction is good. Read these selection statements. Those are good. Multiple selections, single selections, one way in, two way out. Don't need to know how they're done in Ruby or any of the other programming languages mentioned in here. You want to know about iterative statements. And you know what? You might also add in recursion with this, the difference between iteration and recursion, which you probably already know. Counter-controlled loops, logical controlled loops, concept of looping, process control, data control, those things. Unconditional branching. Forget about the historical notes. Unconditional branching is good too. Skip 8.5 guarded commands. Skip, they're not used anymore. Why bother looking at them? Guarded commands, don't worry about the guarded commands. You may have actually, or maybe you have used them, I don't know. Guarded commands are actually supported in C. In fact, you're looking at concept here, where you've got multiple things strung together. I'm not going to ask you about guarded commands. So don't worry about that section. And I shouldn't say, you know, I misquoted here. It's not that they're not used anymore. It's just that I don't think it's real relevant in terms of stuff to focus on. Because if you want to write code that is legible, that's easy to read, that does, you know, that works consistently and that can be well documented, you rarely use the guarded commands. So, and not a lot of languages support them anymore. So read the 8.6 conclusions, so you can skip 8.5. It's not that much reading that you can skip, but read the conclusion. There we go. Review questions, define the selection statement, mention one common misuse of the what? You know what? Skip number 2. I don't even know what those words are. So you don't have to worry about that. But what's the general form of the two-way selector? That's a good one. What mechanism does Python use to specify compound statements? Excuse me. Python is a testable language. So I'm not really doing the final exam review, but I'm doing the textbook review, but I haven't finished selecting the question set for the final exam, but I will tell you, I am planning on putting some questions on the final about Python, Prolog, Scheme, you know, so I will let you know next week the official set of questions and how many you might expect in each category. But for right now, that's the main thought. So if I were to ask you questions about these concepts on the exam, and I were to mention a programming language in particular, it would be, and I'll give you the final list next week, but expect Python, Prolog, Scheme, so the languages that we looked at in this class. So, okay. That concludes chapter number 8. So yeah, the only thing you need to skip is 8.5, guarded commands, or whatever chapter that happens to be in the book version that you have. The rest of it is testable material. Again, chapters 5, 6, 7, and 8. No chapter 9. We did not look at subprograms, so no chapter 9. No chapter 9 for this version of the class. So yeah, I just bombarded you with a ton of information. So I'm going to open up the floor now for any questions that you guys might have. I'll pause for a moment, let you get your breath. Okay.
Professor, I have a question.
Yes.
Like, what is the time till which we can submit our final exam?
The time is going to be in a 5-day window during the final exam week. The university in the past, when we had the face-to-face, had an official final exam week, and you couldn't take the final exam until the final exam week. And the final exam week for this particular summer session is running July 27th through July 31st, which is a Monday through a Friday. So you have to take it by Friday, July 31st. The exam week opens on Monday, July 27th. However, next week I will probably open it up early just in case you want to take it early.
Okay, and so like what will be the time on Friday till we can submit it?
Midnight.
Midnight, like
Midnight on Friday. If you don't do it on Friday, the deadline, the exam will close completely at midnight.
Okay.
I'm not quite sure I would wait that long. I don't have the exam written yet, so I don't know if it's going to be an hour or an hour and a half. It's about the same length as the midterm. You should have plenty of time to take it, and it will auto close at the end of the time. It should be very similar, if not exactly the same format as the midterm exam. Some students did wait until like 11 o'clock at night on the day it was due. I think you're just crazy if you do that. I mean, I would maybe even take it on Thursday just to be sure.
Okay. Yeah. Thank you.
No problem. Thanks for the question. It was an excellent question. Anybody else? I have 2 students.
I also have a question.
Yes, okay.
I have 2. So one is, are notes allowed on the final? And the second one, is there any extra credit?
So there's no extra credit, unfortunately. No extra credit, but I do have a tendency to round up. So for example, if you got 89, I'll give you an A for 90. Or actually 90 is an A minus. The syllabus has the grading scale in there. I do round up, like, you have a 79, that turns into an 80. So I'm not like picky point by point if you're close. Like if you have 79, you're not going to get an 85. You're going to get an 80. So now when it comes to notes, the book, it is supposed to be a closed notes, closed internet, closed book, closed everything exam. I did notice on the midterm, some students were cheating. The questions are designed to prevent cheating. So let me go back to say what I was thinking about originally. When I was, there was actually a purpose to me ranting about the bad information on the internet. I did have some students on the midterm, believe it or not, Google the answers, and I purposely Googled a couple of things just to see what would happen, and they got the answers wrong because the internet had the wrong answers. And one student actually called my attention to it. Hey, look at this website. It says this is the answer. I'm not going to tell you which question it was. And I'm like, well, that means you had internet access during the exam? Okay, so number 1, you're cheating, and that's grounds for 0 on the exam. And number 2, I purposely did that because if you did cheat on the exam, you're going to come up with the wrong answer. Okay, because that's not what the book said. The book said something completely different. So it's not going to be worth your while. I'm not talking to you. I'm talking to general audience right now, by the way. It's not worth your while to Google. You have your exam up on one computer, because if you're using the and you have to use the lockdown browser, it's the same format as the midterm. So lockdown browser, you can't Google, you can't search. So if you have your cell phone out and you're trying to look up the answers, or you're on another computer, number 1, you're probably going to run out of time. And number 2, you're probably going to find the wrong answers. So yeah, to answer your question, no open book, no open notes. The exam will be fairly straightforward, and I think the exam is actually easier than the midterm, usually because the material is easier. It's more relatable because most of you, hopefully all of you, have been programming in a particular language already, so you already know some of these concepts. So, excellent question. I hope I answered it. Or 2 questions. Okay, good.
Professor, I have a question.
Oh, okay.
For the final exam, will there be like a single attempt, or like the best of 3 attempts will be counted?
No, single attempt, only one time.
Okay. Yeah.
I do that because some students take screenshots and stuff, or they try to copy the questions down. and they sit there and they take one pass through with their phone, and then they take another pass through after they looked up all the answers. It's to prevent cheating. And unfortunately, it's sad that it's come to this in this day and age, but you can't trust. And it's not just me, it's just the school in general sets these guidelines. And the guidelines are that you're only supposed to allow one attempt, and it's supposed to be a timed attempt, and you're supposed to use the lockdown browser for it. And it's an attempt to cut down on the level of cheating. And they've done some stats on this. I didn't do these stats. I was basically told these stats. When they compared, if you remember, the spring when we had the pandemic start in and the classes got converted from face-to-face to online, they did a comparison analysis between test scores, and they discovered that there's almost an 80% improvement in student performance when it went to the online environment. So they attributed it to cheating, because how does a student improve by 80% versus face-to-face in class? So I guess there's from a student perspective, you're watching a Zoom meeting, you're out there on your own in isolation, and you're feeling disconnected from your education, or I don't know what you're feeling, but long story short, all the positives to it, hey, you're doing 80% better than you were before. So there's an 80% improvement in your overall performance as a group. And I'm talking about the stats as a group of students. So the students who performed 80% better last quarter, there's the assumption that it's from cheating. It may not be. Maybe some people thrive better in the online environment than they do in the face-to-face one. I don't know. I don't hold it against students, and I don't assume everybody's cheating. But you can't deny some of the stats that come through on this. So I'm just taking the necessary precautions that have been advised to me, and they're the ones that hold an academic standard for the course. We do have to keep up a fairly rigid standard, and it affects the quality of your education as well as the quality of the degree that you're receiving. So you should be happy that we have standards. You should be happy that you can only take it one time and that it is timed, because it means that the value of your degree is higher. So we don't want to see the school go down into the, degree in the mail, sign up for the class, and then in the mail 2 weeks later you receive your A grade in your degree, which turns it sort of into a low quality online education. So we don't want that. Sorry, I guess I'm pretty talkative today. See, I felt bad from last week when we barely had a class. So, we barely had a Zoom session last week. So making up for it this week. Anybody else have any questions?
Professor, one more
Yeah.
question.
Okay.
What kind of question can we expect from the assignment?
Programming in Scheme, programming in Prolog, programming, and I'm talking about basic syntax that would have covered in the assignment scope, and then obviously Python. If I, how do you make it's multiple choice. So a dictionary in Python looks like this, A, B, C. You pick out which is one of the dictionaries. So you don't have to write any code, obviously, but you will have to identify what the code is. And it would be of the scope of the assignment. So if you did a list in Scheme, you're going to have questions about a list. If you did in Python a short circuit evaluation, you might see a question that has some code to ask you, which one of these represents or demonstrates the concept of short circuit evaluation. And it's limited to the scope of the assignments. It's not everything about the language. You're not supposed to be an expert in any of these languages. Just what you did in the assignments is testable. Excellent question. Anybody else? Well, if you do, you can always send me an email message, or next week is the official. So next week, what I'm going to do is tell you there are 10 questions about Python, or there's 5 questions about this, or 5 questions about that. So what you're going to have, I have about 200 questions. I need to go through them and pick out stuff and put them in categories and kind of weigh the categories out. And so next week, I'll tell you how many in this category, how many from chapter 5, how many from chapter 6. And each student is going to receive a different set of questions in a different order. So they're randomly selected, but I can tell you which categories, and the categories are always the same. For example, if 10% of the exams on Python, everybody will get 10% of their questions about Python. Now, which Python questions you're going to get, I don't know, but because they're going to be about, and it's usually about 50-50. There's usually 20. If I were to ask you 10 questions, there's a pool of 20, and students will get a random 10 out of that 20. So it's kind of, it's not a perfect science, but I'm sure that they could probably improve the quality of the test selections, but we'll see. Sorry, I was shaking my table here. Too much coffee. All right. Anything else before we wrap it up this week? Thank you guys for showing. It's nice if I have people to talk to. I don't feel, it makes me feel less alone. So in my shelter in place over here. And here we're going back to shelter in place. It's a good thing I got my hair cut really, really short because the hair salons are closing again. So it took like till June before they opened. Then I got my hair chopped off. And I'm glad I did because it's going to be another 6 months before I can get a haircut again. They closed all the salons. You can't get your hair cut anymore as of last Monday. So anyway, hopefully you guys all got in for haircuts if you have somebody else cut your hair. Anyway, I'm going back to my shelter in place. Unless you guys have any issues or any questions. Are we good? 2 thumbs up. We're good. All right. Well, then I'm going to close out the session for this week. What are these reactions? Oh, yeah. There we go. I can put a thumbs up. Woo-hoo. I just upgraded my Zoom. If you haven't, there's a Zoom upgrade. It gives you these little cool little things. So anyway, thanks for watching. If you do have questions, email me. That's a great way of getting a hold of me. Oh, look at that. Yeah, see, or practice. It's in the lower right-hand corner. It's called reactions. Yeah. Thank you. Thank you. See you maybe I'll see you next week. Next week, I'll have even more details for you, hopefully. All right. Thank you. Have a great rest of your week. I'll see you for week 8 next Wednesday at 9:00 a.m. We're getting down the home stretch here. Okay. Bye-bye.